In this video lecture, there will be a detailed discussion about passive circuit elements. This is the first part of this lecture in which we'll be discussing about linear resistors. Now, what is a passive circuit element? A passive circuit element refers to any device or a component which does not introduce gain or does not have directional function. In other words, such components conduct current in either direction and therefore are known as bilateral devices. In actual practice, the most commonly used passive circuit elements are the following three types: resistors, inductors, and capacitors. A resistor is an electrical component which has been manufactured with specified amount of resistance. The resistors can conduct current in both the directions. Thus, the resistors may be connected in an electric circuit without concern for lead polarization. Now, where is this resistor used? It is used mainly for two purposes, namely controlling the flow of electric current and providing desired amount of voltage in electric or electronic circuit. Now let us discuss resistor specifications. The resistors are specified in terms of their resistance values, tolerance, power rating, and thermal stability. By tolerance, we mean the allowed variation permitted in the normal or marked value of the resistor. It means that the actual value of the resistor may be either greater or smaller than that of the indicated value by a factor given by the specified tolerance. Thus, resistors are manufactured with a specified tolerance. For example, a 5000 ohm resistor with a tolerance of plus minus 10% will have an actual resistance value anywhere between 4500 ohm and 5500 ohm. In other words, 500 ohm greater or smaller than the rated value. Next is power rating. The power rating of a resistor is given by the maximum wattage it can dissipate without excessive heating. Since the power rating is proportional to the square of a current, therefore current must not be higher than its safe value. If the current exceeds the safe value, the resistance will burn out. Thus, in order to increase the life of resistors, these must be used at much less power than their rated values. A standard practice is to use a power dissipation of about half of the rating of the resistor. The thermal stability of a resistor is indicated by the temperature coefficient specification, which is usually expressed in parts per million per degree centigrade. The smaller value of temperature coefficient will have less variation in the resistance value. Therefore, smaller value of temperature coefficient means a higher thermal stability of a resistor.